Hello everyone, this is Prasad and I welcome all of you for another lecture on hybrid electric vehicle. In previous lecture, we understood how DC motor works, how its actually working principle is coming into existence. Like we understood the Fleming's left hand rule, which gives us understanding of the direction of the force. We also understood that when we place current carrying conductor in magnetic field, it experiences a force, and this is the principle on which DC motor works. We also understood various types of DC motor, maybe DC series motor, DC shunt motor, DC compound motor. We also understood its applications, like DC series motor is used for traction application. In railways, we are using DC series motor. Also, we understood that DC shunt motor is used for constant speed operations. In today's lecture, we are going to understand in detail the AC motors. So let's start the session. Guys, AC motors are one of the most important motors, and the innovation of AC motors, the big contribution was of Nikola Tesla. Nikola Tesla is having over 450 patents on his name, and three-phase induction motor is one of his most renowned and usable patent in case of sector of engineering. In India, not in India, I would say abroad, we are using across the world, we are using three-phase induction motors as one of the major source of conversion media from electrical energy into mechanical energy. Maybe you want to run lathe machines or conveyor belts or drilling machines or milling machines. Everywhere we are using three-phase induction motor. Also, in one of the most renowned manufacturing companies of electric vehicle like Tesla, most of the vehicles of Tesla are using three-phase induction motors. So three-phase induction motors are a type of AC motor. So let's understand how AC motor works. So AC motor converts the alternating current that reverses direction at regular intervals into mechanical power. Now alternating current is, we are considering a sinusoidal current. So this is the x-axis on which we are considering theta, and on y-axis if we consider voltage, then a sinusoidal voltage waveform will look like this. Now this is a single phase sinusoidal voltage waveform. If it is a three-phase sinusoidal voltage waveform, there are going to be three-phase voltages. So there will be three waveforms displaced by 120 degree with respect to each other. So what happens in AC motor is, you are providing an alternating current to a motor as input, and it is going to convert that into mechanical energy. So there are mainly two types. One is a synchronous motor and one is the induction motor. Okay, now we'll understand these two in detail. So if you see synchronous motor, or if you see synchronous and induction both of the motors, there are two conditions for torque production. First of all, both stator and rotor must produce magnetic field. This is very much important because ultimately the force or the torque which is getting produced is due to interactions of the magnetic fields. So there is the condition that both the stator and rotor should produce the magnetic field. There will be interaction of these two magnetic fields, and further there will be production of the torque. Second, number of magnetic poles of stator must be equal to number of magnetic poles of the rotor. So when we understood the DC motor, I told you that there is a yoke, which is nothing but a part which is circular and is a stationary. On that we are placing the poles. Okay, so in DC motor also there are poles on which you are placing the windings which are carrying DC current. In case of AC motor also, the rotor and stator are going to have poles, but we have to make sure that both stator and rotor are having same number of poles. Both poles, when are carrying current, they are producing magnetic field. So both are interacting, both the magnetic fields are interacting with each other, and there is production of torque. So let's go ahead and understand, in order to produce this continuous torque, the magnetic field of the stator should be rotating continuously. That is called as rotating magnetic field. So it is simply called as RMF. Okay, so this is the main thing in case of three-phase machines, is that three-phase machines are capable of producing rotating magnetic field, and that's why they are called as self-starting. If you are sitting under the ceiling fan right now, on the top of your head there is ceiling fan. That ceiling fan is also having single phase induction motor. But single phase motors are not self-starting. They require some media for developing rotating magnetic field. Simply put, it is having a capacitor. The ceiling fan that you are seeing on your on your ceiling is carrying capacitor also. If you remove the capacitor, the fan won't work. In same way, wherever there is single phase induction motor, maybe your mixer, maybe your grinder, okay, everywhere there is a single phase induction motor, you require capacitor because single phase motors are not self-starting. But three phase motors are self-starting because they produce rotating magnetic field, as there are three voltages. This is the one voltage waveform that I have drawn. There will be another voltage waveform and there will be third voltage waveform. So there are three voltage waveforms existing. They are displaced by 120 degree with respect to each other. This angle is 120 degree, and hence they are capable of producing rotating magnetic field, which leads to production of rotating torque or continuous torque. Okay, so rotor magnetic field follows this stator magnetic field. So once the stator is carrying the three phase current, these three phase currents are going to produce rotating magnetic field, and automatically the rotor magnetic field is going to follow the stator magnetic field. Okay, so here the most important thing is the cause for the rotation of rotor is nothing but the magnetic field that is produced by the stator. It's pulling the magnetic field that is produced by the rotor. Means simply put, if there is north pole on the rotor, okay, stator, if there will be south pole on the stator, so what will happen? There will be force of attraction. So rotor will be continuously following the stator magnetic field and there will be rotation.